Hi students, today I am going to deal the topic PLC components from the chapter Introduction to PLCs. PLC component from the chapter Introduction to PLCs. Learning objectives. Upon completion of this presentation, you will be able to understand the concepts of the block diagram of PLC, a brief explanation of the block diagram and the various components of the block diagram, that is the PLC components. They are the input module, the central processing unit, the programmer and the monitor, or the output module, the rack and the chassis, and the PLC operation cycle. Upon completion of this presentation, you will be able to understand the basic concepts of the block diagram of PLC and its explanation, the PLC components, the input module, the central processing unit, the programmer and the monitor, the output module, the rack and the chassis, and the PLC operation cycle. This is the basic block diagram. So before going into the block diagram of PLC, I would like to review what is PLC. PLC stands for Programmable Logic Controller. It is a computer which is specially designed to operate reliably under harsh industrial environments such as extreme temperatures, wet or dry and or dusty conditions. So it is a computer which is specially designed to operate reliably under harsh environments such as extreme temperatures, wet and dry or dusty conditions. So it is used to automate an industrial process such as manufacturing plants or assembly line, an ore processing plant or a wastewater treatment plant. So wastewater treatment plant. So PLCs play a very crucial role in the field of automation. They were invented by Dick Morley in 1964. They have revolutionized the industrial and manufacturing sectors. There are a wide range of PLC applications or functions like timing, counting, calculating, comparing and processing various analog signals. So the main advantage of the PLC over hardwired control systems is that they are programmed. In a hardwired control system, you are essentially having to rip out the wires and start from the scratch, which is more expensive. Suppose you have a light connected to a switch. In general, the light operates under two conditions. I would like to just give you an example why we need PLCs. In general, the light operates under two conditions, on and off. Now you are given a task that when you turn on the switch, the light should glow only after 30 seconds. Okay, this is the condition which you want to implement. That is, when you are turning on the switch, the light should glow only after 30 seconds. With this hardwired setup, we are stuck because the only way to achieve this is to completely rewire our circuit to add a timing relay. You have to rewire your wired circuit and add a timing relay. So that's a lot of hassle for a small minor change to just switch on the light after 30 seconds. To allow the light to glow after we switch on for 30 seconds. So this is where a PLC comes into picture, which doesn't require any additional wiring and hardware to make sure of the change. Rather, it requires a simple change in the code, that is the programming the PLC to turn on the light 30 seconds after the switch is turned on. So by using a PLC, it is easy to incorporate multiple inputs and outputs. This is just a simple example. A PLC has the ability to control much larger and more complex processes. So PLCs can be customized depending upon the application and the needs of the user. depending upon the application and the needs of the user. So the basic block diagram of a PLC, it is nothing but a computer, as I told you earlier, which consists of a power supply. We have the input module, the output module, the CPU, which and a central processing unit, the programming device, the memory, then the input devices and sensor, the output devices and the loads. You can see in the picture, you have the input module. The input can be either analog or digital. We have push button switches, we have liquid level switches, we have limit switches, we have pressure switches, which are the input devices, and then on the output side you have the motor, the solenoid, the speaker, the light or the horn, whatever it may be. So this is the basic block diagram of a programmable logic controller. So the major units of PLC are input module, central processing unit, the CPU, the programmer or the monitor, the output module, the racks and the chassis. So we have the major units of the PLC are the input module, the central processing unit, that is the CPU, the programmer or the monitor. Then we have the output module, the racks and the chassis. So the input devices, as we have seen in the block diagram, to the input module, you give the input to the input module using input devices. So the input devices of a PLC can be either analog devices or digital devices. They can be analog, like you can use sensors. The analog devices are thermocouples, thermistors, tachometers, pressure transducers, flow meters, level sensors. All these are the analog devices. The digital devices are, we have push buttons, we have selector switches, we have limit switches, we have level switches, we have photo sensors, we have proximity sensors. So the input devices, input to the PLC, the first block of your block diagram is your input module. So you're giving an input signal to the PLC. The input signal can be an analog signal or a digital signal. So we use analog devices as input devices to the PLC, and we use digital devices as input devices to the PLCs. The analog devices are the sensors like the thermocouples, the thermistors. Thermocouples convert heat energy into electrical energy. Thermistors convert the heat energy into change in resistance. Tachometers, they convert speed into displacement. Then pressure transducers, pressure sensors we have, which convert the pressure signal into corresponding analog electrical signal. The flow meters, flow is being converted into corresponding analog signal. Level sensors we have. Coming to the digital devices, we have push buttons, the selector switches, the limit switches, the level switches, the photo sensors and the proximity sensors. So these are the different types of input devices of PLCs. The next is your output devices. You can see in the block diagram, the output devices are, we have seen the motor as the output motor starters. We have the relays, the contactors, the solenoid coils, we have the lamps or sometimes the horns, alarm may be there. So these are the output devices. So output devices are actuated by the output module. They are actuated by the output module. So the units of PLC are, we have three major sections. Three major sections are there. Basic sections are there in a PLC. In the basic structure of the PLC, we have the I/O section, the processor section, the program loader or monitor section. Okay, we have three sections: the I/O section, input output section, the processor section, the program loader or monitor section. So what is happening in the input section? The input section converts the field signals to logic level signals. The input section converts the field signals to logic level signals that the PLC processors can read directly. So from the input section, from the input module, the signal goes to the processor. So the input section, what does it do? It converts the field signals to the logical level signals that the PLC's processor can read directly. Then the second section is your processor section, which reads these inputs, processes the signals, execute the program and prepares the output signal. So the processor section, I'm sorry, it is not process section, but processor section, which reads these inputs, the inputs from the input section, processes the signals, execute the program and prepares the output signals. The output section converts the logic level output signals coming from the processor section into high level signals and release the signals for various field devices. So what does the output section do? It converts the logic level output signals coming from the processor section into high level signals and release the signals for various field devices. So the output section, it converts the logic level output signals that are coming from the processor section into high level signals and release these signals for various field devices. The program loader or the monitor section is used to enter the user's program into a memory or change it and to monitor the execution of the program. So what does the program loader do? Program loader is used to enter the user's program. It is used to enter the user's program into memory or change it and to monitor the execution of the program. Your program will be executed by the program loader. So you need to enter the user program into the memory and then make the changes, and it is used to monitor the execution of the program. So the physical structure of let us see the physical structure in depth, the detailed structure of your PLC. The structure of PLC is almost similar to a computer's architecture. It is almost similar to a computer's architecture. You can see the figure. You have the input module, the central processing unit, the output module. You have the programming device where you can load your program. The input sensing devices, different types of sensing devices are there, and we have the output devices also, and the programming device is also used. So this is a structure of a PLC which is similar to a computer's architecture. Then programmable logic controller, it continuously monitors the input values which are coming from various input sensing devices. As I told you, we have the analog or digital devices, example accelerometer, weight scale or hardwired signals, etc., and produce corresponding output depending on the nature of production and industry. Depending upon the nature of the production and the industry, it will continuously monitor the input values from various input sensing devices and produce a corresponding output depending upon the nature of production and the industry. Typically, the block diagram consists of 5 important parts, namely rack or the chassis, the power supply module, the central processing unit, input and output module, and communication interface module. So the block diagram of a PLC consists of 5 parts, namely the rack or the chassis, the power supply module, the central processing unit, input and output module, communication user interface module. So we have the 5 parts, the rack and the chassis, the power supply module, the central processing unit, that is the CPU, the input and output module, and the communication interface module. So the first component is your rack or the chassis. It is the rack or the chassis. In all PLCs, the PLC rack or chassis forms the most important module, and it acts as a backbone to the system, to the entire system. This rack or the chassis, it acts as a backbone. In all PLCs, the rack or the chassis forms the most important module. It is like a backbone to the system. The PLCs are available in different sizes and shapes. So when more complex control systems are involved, it requires larger PLC racks. Small size PLCs is equipped with an fixed I/O pin configuration. So these racks and chassis also, they have their own configuration. So they have gone for modular type rack PLC, which accepts different types of input output modules with slide and fit in concept. They have slide and fit concept. Okay, and all input output modules will be residing inside the rack chassis. So we have you can see in the figure, we have the power supply at the lowest part, then the CPU, central processing unit, then your I/O, input output section. So the rack is holding the entire unit of the PLC. So it is like a backbone, it is like a support. It holds the PLC. It may be of different sizes and shapes. The modular type of PLCs which accept different types of I/O modules with sliding and fit-in concept. You have the different modules there, digital inputs and other things. The I/O section we have. So this is your rack or the chassis. The second one is your power supply module. The power supply module, this module is used to provide the required power to the whole PLC system. As we have seen in the earlier figure, we have the power supply module at the bottom. It is used to provide the required power to the whole PLC system. What does this power supply module do? It converts the available AC power into DC power, which is required by the CPU and the I/O modules. The CPU and the I/O modules, they work on DC supply. Hence, you need to convert the AC power into DC power. So, power supply module converts the AC power into DC power. PLCs, they generally work on a 24 volts DC supply. They generally work on a 24 volt DC supply. Few PLCs uses an isolated power supply. Sometimes some PLCs also use isolated power supplies. Generally, a 24 volts DC power supply is used. So the AC power should be converted into DC power because to run your CPU and I/O modules. Then the CPU module and the memory. The CPU module has a central processor. The CPU module has a central processor, the ROM and the RAM memory. The CPU module consists of a central processor, the RAM and the ROM memory. ROM memory includes an operating system, drivers and application programs. RAM memory is used to store your programs and data. You have two types of memories, ROM memory and RAM memory. ROM memory, it includes an operating system, the drivers and the application programs. RAM memory is used to store the programs and the data. So CPU is the brain of the PLC with an octal or hexagonal microprocessor. We have an octal or a hexagonal microprocessor. Being a microprocessor based CPU, it replaces timers, relays and counters. Two types of processors as a single bit or word processor can be incorporated with a PLC. Single bit word processor can be incorporated with a PLC, and also you can use a single bit or word processor can be incorporated with the PLC. So CPU module has the central processor, ROM and RAM memory. ROM memory includes an operating system, drivers and application programs. RAM memory is used to store the programs and the data. CPU is the brain of the PLC with an octal or hexagonal microprocessor. Being a microprocessor based CPU, it replaces timers, relays and counters. Two types of processors as a single bit or word processor can be incorporated with the PLC. One bit processor is used to perform logical functions, whereas word processors are used for two types of processors. I told you, one bit processor, it is used to perform logical functions. Word processor are used to process text, numerical data, controlling and recording data. So the word processor does all these things. It processes the text, the numerical data, the controlling and recording data. CPU reads the input data from the sensors, processes it and finally sends the command to the controlling devices. So what does the CPU do? It reads the input data from the various sensors, processes the data and finally it sends the command to the controlling device. So DC power source as mentioned in the is required voltage signal. So CPU also contains only electrical parts to connect the cable used by other units. Okay. Then next comes your input module, input output module. So to sense physical parameters like temperature, pressure, flow, etc. using PLC, an exclusive module for interfacing input and output is called an input-output module is used. So to sense the physical parameters may be like temperature, pressure, flow, viscosity, velocity, all these are the physical parameters. Using PLC, you need an exclusive module of interfacing for interfacing the inputs and the outputs. So this type of module is called input-output module. Input devices can be either start and stop type. It may be either push buttons or switches, etc. And the output devices can be an electric heater, it can be a valve, it can be a relay, it can be a light or a lamp. Okay. So IO modules help to interface input and output devices with your microprocessor. So the IO module or the input-output module, it senses to sense the various physical parameters. An exclusive module is used for interfacing the input and the output, and that module is called input-output module. The input devices can be either you can start or stop a process by using push buttons or switches, etc. The output devices can be an electric heater or a valve or a relay, etc. So input-output module helps to interface input and output devices with your microprocessor. So this is your basic block diagram of your input module. You have a power section and the logical section. The power section is the input module. You have AC voltage source of 12 volt, 120 volts AC signal. AC is being converted into DC using a bridge rectifier circuit and a Zener diode level detection circuit also we have. Then you are going to use an isolator. The output is given to the isolator, and from the isolator it runs the signal is given to your logical section. From the logical section it is given to your processor. 5 volts DC supply is given to your central processing unit. So this is the circuit diagram of your input module. We have an AC source. AC is being converted into DC using a bridge rectifier circuit, full wave rectifier circuit we use. Then we have Zener diode voltage regulator and an isolator circuit and the isolator circuit output is 5 volts DC which is given to your processor. logical circuit we have. So the input module does four main functions. The input module interface receives the signal from the process device at 220 volts DC. So what does the input module do? It receives the signal It does four main functions. Input module interface receives a signal from the process device at 220 volts AC. Converts the input signal to 5 volts DC that can be used by PLC. So it converts the input signal to 5 volts DC that can be used by the PLC. Then the isolator block is used to isolate or prevent PLC from undergoing fluctuations. So the isolator block is used to isolate or prevent PLC from undergoing fluctuations. So the input module interface receives the signal from the process device at 220 volts, converts the input signal to a 5 volt DC which can be used by the PLC. So you are using an isolator block to isolate or prevent PLC from undergoing fluctuations, after which the signal is sent to the output end, that is the PLC. Excuse me. So there are two main sections in the input module, namely the power section and the logical section. As I told you, we have two sections, the power section and logical section. Both are electrically isolated from each other. Initially, what is happening when you push the button, when you push the button, it is closed, the circuit is closed, and so 220 volts AC supply is given to the bridge rectifier circuit through the resistors R1 and R2. The bridge rectifier is used to convert your AC signal into DC, and Zener diode is used to provide low voltage supply to the LED. When the light from the LED falls on the phototransistor, then it begins to work in the conduction region, and hence finally a 5 volt DC supply is given to your processor. So you are using an isolator section also. So there are two main sections in the input module, namely the power section and the logical section. Both the sections are electrically isolated from each other. They are electrically isolated from each other. Initial push button is closed. So 220 volts AC supply is given to a bridge circuit through a resistor R1 and R2. The bridge rectifier is used to convert your AC signal into DC, and a Zener diode is used to provide a low voltage supply to the LED. When the light from the LED falls on the phototransistor, it works in the conduction region. Finally, a 5 volts DC supply is given to the processor. Then your next section is your output module. The output module of the PLC works similar to the input module, but in the reverse process. It interfaces the output load and the processor. It works in a reverse process compared to the input module. It interfaces the output load and the process. So here the first section would be the logical section, and the second will be the power section. Whereas there the first section is your power section and then the logical section. So here it interfaces the output load and the processor. So a digital signal from the processor is given to your logical section, and from that output of the logical section is given to your power section. The working of the output module is, when the logic high signal is generated from the processor, LED will turn on and allow the light to fall on the phototransistor. It allows the light to fall on the phototransistor. When logic high signal is generated from the processor, LED will turn on, the light emitting diode will turn on and allow the light to fall on the phototransistor. When the transistor goes to conduction region, it generates a pulse to the gate of the triac. The isolator block is used to isolate the logic section and the control section. we have the power section or the control section. So you need an isolator block to isolate both the sections, the logic section and the control section. Next is your communication interface module. Communication interface module is used to transfer information between the CPU and the communication networks. Intelligent input-output modules are used here. So it is used to transfer the information between the CPU and the communication network. These communication modules help to connect with other PLCs and computers which are placed at a remote location. They are used to connect other PLCs and computers which are placed in remote locations also. So communication interface module is used to transfer the information between the CPU and the communication network. Intelligent IO modules are used here. So these communication modules, they help to connect with the other PLCs and computers which are placed at a remote location. They help to connect with the other PLCs and computers which are placed at remote location. So coming to the operation of your PLC, as I told you earlier, your programmable logic controller, it is a user-friendly computer that executes a predetermined program which is stored inside the non-volatile memory. So its purpose is to monitor crucial process parameters and adjust process operations accordingly. Okay, its purpose is to adjust the process parameters, process operations accordingly. So the PLC can be operated on the input side. You can operate the PLC by analog or digital input devices. So field devices such as level switches, pressure switches, flow meters, as I showed you in the block diagram, they are connected to the system input. So the PLCs can drive analog or digital output devices. Motors, solenoid valves and other electronic devices are connected to the output devices. Programming is done using a specific technique called ladder logic. You are going to use a specific technique called ladder logic, which allows sequences of logic actions. Okay, so programming is done which allows sequence of logical actions to be set up, interlinked and timed. So what is happening? The programming is done using a special technique called ladder logic, which allows sequence of logic actions to be set up, interlinked and timed. So PLC is most commonly used industrial automation technique all around the world. It is used for factory automation, manufacturing systems, process control systems. Okay, so these are the applications of PLCs. So PLC, it can be operated on the input side by the analog and digital devices. So working of a PLC can be understood as a cyclic scanning method known as scan cycle. There is a method called scan cycle, your organizational block. So you can see in the flow chart for the how the PLC works. Start cycling, time monitoring, read data from the input module, user program working, write data into the output module and do the other tasks. Again it is repeated. As I told you, what does it do? It takes information input from the input devices or the field devices. Then these input devices, after taking the information from the input devices, the programming is done using a technique called ladder logic, which allows sequence of logic actions to be set up, interlinked and timed. And after that the output is driven. So PLC can drive the analog output or digital output devices. So the PLC scan process consists of the following steps, as we have seen in the figure earlier there. What does the PLC scan process consists of? The PLC scan process consists of the following steps. What are the steps? The operating system starts cycling and monitoring of the time. The operating system starts cycling or monitoring of the time. Then the CPU starts reading the data. So what is actually happening? A sensor or a device converts a physical condition into an electrical signal, which can be either discrete or analog signal, digital signal or analog signal. These are given as input to the central processing unit. Memory of the they are given as input to the CPU. So the CPU makes the decisions, it issues control instructions based on the memory resident program, and output module converts the control instructions from the CPU into a digital or analog signal that can be used to control various field devices, that is the actuators. So the programming device is used to input the desired program. The program determines the PLC will do what the PLC will do for a specific input. So an operator interface device allows process information to be displayed and new control parameters to be entered. So in the PLC scan process, the operating system starts cycling and monitoring of the time. The CPU next, what does it do? The CPU starts reading the data from the input module and checks the status of all the inputs. Then the CPU starts executing the user or application program written in relay or ladder logic or any other PLC programming language. Next, the CPU performs all the internal diagnosis and communication tasks. According to the program results, it writes the data into the output module so that all the outputs are updated. This process continues as long as the PLC is in run mode. So what is the logic in the PLC scanning? The PLC program is executed as a part of repetitive process which is referred to as scan. A PLC scan starts with the CPU reading the status of the inputs. The application program is executed using the status of the inputs. Once the program is completed, the CPU performs internal diagnostic and communication tasks. The scan cycle ends up by updating the outputs. So this cycle repeats continuously. So the cycle time depends upon the size of the program, the number of input-output sections and the amount of communication required. So the operating system in the PLC scan process, what does it do? The operating system starts cycling and monitoring of time. The CPU starts reading the data from the input module and it checks the status of all the inputs. Then the CPU starts executing the user or application program written in relay, ladder logic or any other PLC programming language. Next, the CPU performs all the internal diagnosis and communication tasks. According to the program results, it writes the data into the output module so that the outputs are updated. This process continues as long as the PLC is in run mode. So to summarize our topic of discussions today, I have dealt with the block diagram of PLC. The major blocks of a PLC logic or a programmable logic controller consists of the input module, the CPU, the output module, the power supply, the programming device and the memory. We have the input devices and the sensors and the output devices and the loads. The input devices and the sensors may be a push button switch or an liquid level switch, or it may be a limit switch or a pressure switch. The output devices may be a motor or a solenoid or a speaker or a light or a bulb which glows. So the major units of a PLC section are the input module, the central processing unit or the CPU, the programmer or the monitor, the output module, the racks and the chassis, the PLC racks and the chassis. So the input devices of the PLC can be the input devices. They can be either analog devices or digital devices. Analog devices are, we have sensors like thermocouples, thermistors, tachos, pressure transducers, flow meters and level sensors are used. The digital devices can be push button or a selector switch or a limit switch or level switches or photo sensors or proximity sensors. Coming to the output devices of the PLCs are relays, contactors, solenoid coils, motor starters, lamps and horns. The units, different basic units of the PLC section consists of IO, input output section, the processor section, program loader or monitor section. The input section, it converts the field signals to logical level signals that the PLC processors can read directly. The processor section reads these input processes the signals executing the program and prepares the output signals. The output section converts the logic level output signals coming from the processor section into high level signals and release the signals for various field devices. The program loader or the monitor section is used to enter the user's program into the memory or change it and to monitor the execution of the program So the physical structure is similar to a computer architecture, where we have the input module, the central processing unit, the output module, the output devices and the programming devices. Basically we have the five important parts: the rack or the chassis, the power supply module, the central processing module, the input and output module, and the last one is your communication interface module. So these are the basic five parts in a PLC: the rack or the chassis, the power supply module, the central processing unit, then we have the input and output module, the communication interface module. So the rack and the chassis, the rack is the important module which acts as a backbone to the system. It holds the PLC. When we have these PLCs are available in different sizes and shapes. When more complex control systems are involved, it requires larger PLC racks. Small size PLCs is equipped with a fixed IO pin configuration. So they have gone for modular type rack PLCs, which accepts different types of input output modules with sliding and fit in concept. So the input output module will be residing inside the rack or the chassis. The power supply module is used to provide the required power to the entire PLC system. It converts the available AC power to DC power, which is required by the CPU and the input output module. So the PLC generally works on 24 volts DC power supply. Few PLCs also have isolated power supplies. Then your next part is your CPU module and memory. The CPU module has a central processor, a RAM and ROM memory. ROM memory includes an operating system, the drivers and the application programs. It includes an operating system, the driver and the application programs. RAM memory is used to store the program and the data. What does the RAM memory do? It is used to store the program and the data. ROM memory, it includes an operating system, drivers and application programs. CPU is the brain of the PLC with an octal or hexagonal microprocessor. So being a microprocessor based CPU, it replaces timers, relays and counters. So two types of processors, that is a single bit processor or a word bit processor is incorporated. In a single bit processor, it is used to perform logical operations or logical functions, whereas word processors are used for processing text, numerical data, controlling and recording the data. So CPU reads the input data from the sensors, processes it and finally sends the command to the controlling devices. So DC power source is used and also CPU also contain other electrical parts to connect cables used by other units. Then the input output module. So to sense the physical parameters like temperature, pressure, flow, etc., PLCs are exclusively they have an exclusive module for interfacing the input and the output, which is called input output module. So input devices can either start or stop the push buttons, switches, etc., and output devices can be electric heaters or valves or relays, etc. So the input output module helps to interface the input and the output devices with the microprocessor. So the input modules has four main major functions. It receives, this module interface receives the signal from the process devices at 220 volts AC. So it converts the input signal to 5 volts DC, and you can have sometimes an isolator block is also used to isolate or prevent the PLC from undergoing fluctuations. After this the signal will go to the PLC. So there are three main sections in the input module: the power section and the logical section. Both sections are electrically isolated from each other. Initially, when the button is pushed or when the circuit is closed, 220 volts AC supply is given to the bridge rectifier, which converts AC into DC, and we have a Zener diode circuit which is used to provide low voltage supply to the LED. When the light from the LED falls on the phototransistor, it works in conduction region, and finally a 5 volt DC supply is given to your processor. The output module of the PLC works similar to the input module, but in the reverse process. Here it interfaces the output of the load and the microprocessor. So here the first section would be the logical section, and then your power section. So when the logic high signal is generated from the processor, LED will turn on and allow the light to fall on the phototransistor. When the transistor goes to conduction state, it generates a pulse to the gate of the triac. So the isolator block is used to isolate the logic section and the control section in the output module. Then lastly we have the communication interface module. This module is used to transfer information between the CPU and the communication networks. Intelligent I/O modules are used. These communication modules help to connect with other PLCs and computers which are placed at a remote location. So communication modules help to connect to with the PLCs, other and computers which are placed in remote location. So the output, so this is about your communication module. Then we are left with the operation cycle of the PLC. The PLC can be easily understood as a cyclic scanning method known as the scan cycle. The steps that are followed in the PLC scanning process is: the operating system starts cycling and monitoring of time. The CPU starts reading the data from the input module and it checks the status of all the inputs. The CPU starts executing the user or application program written in the relay ladder diagram or relay ladder logic or any other PLC programming language. So next, the CPU performs all the internal diagnosis and communication tasks. So according to the program results, it writes the data into the output module so that the outputs are updated. So this process continues as long as the PLC is in running mode. This process continues as long as the PLC is in running mode. So with this, we have discussed about the block diagram of PLC in detail, the various components of the PLC, how they are designed, that is the input module, the output module, the central processing unit, the programmer and or the monitor, and the rack and the chassis, the role of the rack and the chassis in PLCs. And we have studied about the operation cycle of the PLC, that is the PLC scanning method also we have studied. So with this, I would like to end my presentation today. Thank you.